the interpretation is correct. Conduit, when utilized as a sleeve for Romex branch circuit feeds entering a panel or load center in a surface-mounted scenario, is prohibited from penetrating the structural ceiling as per the relevant exceptions in the electrical code. This requirement's primary objective is to mitigate the risk of fire propagation from the attic to the living space. A conduit penetrating the structural ceiling creates a potential pathway for flames and smoke to traverse, compromising fire safety. Most electrical inspectors will enforce this violation due to the significant safety hazard it poses. If a contractor is observed employing conduit as a sleeve for Romex feeds in a manner that violates this code provision, reporting it to the local building department is recommended. The purpose of this code is to stop the spread of fire from one space to another in the building. The code will address the installation methods for electrical equipment and wiring to minimize fire hazard. The code specifies that wiring methods and materials must be suitable for the environment in which they are installed. The code requires that electrical equipment be properly grounded to prevent electrical shock hazards. The code requires that overcurrent protection devices be installed to protect circuits from overloads and short circuits. The code requires that ground fault circuit interrupters, known as GFCIs, be installed in areas where there is a high risk of electrical shock. The electrical inspectors play a vital role in enforcing the electrical code and ensuring that electrical installations are safe. There are several types of conduit approved for electrical installations. Firstly, rigid metal conduit, RMC, is a heavy-duty, threaded tubing, generally made from steel, offering exceptional protection for conductors. RMC is suitable for both exposed and concealed locations, and is often used in industrial settings or where physical damage is a concern. Secondly, intermediate metal conduit, IMC, is a thinner and lighter alternative to RMC, while still providing good protection for conductors. IMC is also suitable for both exposed and concealed locations, and is frequently used in commercial and industrial applications. Thirdly, electrical metallic tubing, EMT, commonly referred to as thin wall conduit, is a lightweight, unthreaded tubing typically made from steel or aluminum. EMT is suitable for concealed and some exposed locations, providing protection for conductors against physical damage. Fourthly, flexible metal conduit, FMC, is a spiral wound, flexible tubing, allowing for bends and movement in electrical raceways. FMC is used in dry locations primarily, offering protection for conductors in short runs or where flexibility is required. Fifthly, liquid-tight flexible metal conduit, LFMC, is a flexible metal conduit covered with a waterproof plastic coating, designed for use in wet locations. LFMC provides protection for conductors against moisture, chemicals, and physical damage. Sixthly, rigid polyvinyl chloride conduit, PVC, is a non-metallic conduit made from PVC, offering resistance to corrosion and chemicals. PVC is suitable for underground and direct burial applications, as well as some exposed locations. Seventhly, electrical non-metallic tubing, ENT, is a flexible, non-metallic conduit, often referred to as Smurf tube, suitable for use in walls, floors, and ceilings. ENT is lightweight and easy to install, providing protection for conductors in dry locations. Romex, formerly known as NMB cable, is a type of electrical wiring commonly used for residential branch circuits. NMB cable consists of two or more insulated conductors and a grounding conductor enclosed within a non-metallic sheath. NMB cable is suitable for use in dry locations only, and is typically installed within walls, floors, and ceilings. When installing Romex wiring, it is important to follow all applicable codes and regulations to ensure safety. The NEC provides detailed requirements for the installation of Romex wiring, including conductor sizing, overcurrent protection, and grounding. Firstly, conductor sizing is determined by the ampacity of the circuit and the type of wire used. The NEC provides tables that specify the allowable ampacities for different wire sizes and insulation types. Secondly, overcurrent protection is provided by circuit breakers or fuses, which are designed to trip or blow in the event of an overload or short circuit. The NEC specifies the maximum allowable overcurrent protection for different circuits. Thirdly, Grounding is essential for preventing electrical shock hazards. The NEC requires that all electrical equipment and wiring be properly grounded to a grounding electrode system. The grounding electrode system typically consists of a grounding rod, a ground ring, or a metal water pipe that is connected to the earth. There are several common electrical code violations to be aware of. One is the use of undersized conductors. Using conductors that are too small for the intended load can cause overheating and fire hazards. It's important to select the correct conductor size based on the ampacity of the circuit and the applicable code requirements found in NEC Table 310.15. Another common violation is improper grounding. Failure to properly ground electrical equipment and wiring can create a risk of electrical shock. It's essential to follow the NEC guidelines for grounding and bonding to ensure a safe electrical system. Overcurrent protection is also frequently violated. Using the wrong size or type of overcurrent protection device can lead to equipment damage or fire hazards. It is important to use the correct size circuit breaker or fuse for each circuit, as specified by the NEC. Another violation is improper wiring methods. Using unapproved wiring methods or failing to protect wiring from physical damage can create safety hazards. It's important to use approved wiring methods and to protect wiring from damage by using conduit, raceways, or other protective measures. Another frequent violation is working without permits or inspections. Performing electrical work without obtaining the necessary permits or inspections can result in unsafe installations and code violations. It's important to obtain all required permits and inspections before starting any electrical work. The proper installation of electrical panels is essential for safety and compliance with electrical codes. The electrical panel must be installed in a location that is easily accessible and free from obstruction. The NEC specifies minimum clearances around electrical panels to allow for safe access and maintenance. The electrical panel must be securely mounted to a wall or other suitable support structure. A panel must be installed level and plumb to ensure proper operation of the circuit breakers. The electrical panel must be properly grounded to prevent electrical shock hazards. The grounding conductor must be connected to the grounding electrode system. The electrical panel must be properly labeled to identify the circuits that are connected to each breaker. The labeling must be clear and accurate to prevent confusion and errors. The electrical panel must be kept clean and free from debris. Dust, dirt, and other contaminants can interfere with the operation of the breakers and create fire hazards. The overcurrent protection devices, circuit breakers or fuses, must be properly sized to protect the conductors from overloads and short circuits. The size of the overcurrent protection device must be based on the ampacity of the conductors. All wiring connections within the electrical panel must be made securely and properly. Loose or corroded connections can cause overheating and fire hazards. The panel should be inspected regularly for any signs of damage, overheating, or loose connections. Any problems should be corrected immediately by a qualified electrician. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. The NEC is developed and published by the National Fire Protection Association, known as the NFPA. The NEC is updated every 3 years to reflect changes in technology and best practices. The NEC is not a law, but it is widely adopted by state and local governments as the basis for their electrical codes. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is divided into chapters, articles, and sections, each addressing a specific aspect of electrical safety. The NEC is a complex and comprehensive document that requires careful study and understanding. Electricians, inspectors, and other electrical professionals use the NEC as a guide to ensure that electrical installations are safe and compliant. The NEC is constantly evolving to keep pace with new technologies and changing safety requirements. Staying up to date on the latest edition of the NEC is essential for anyone working in the electrical industry. The NEC is an important tool for preventing electrical fires and injuries. By following the requirements of the NEC, electrical professionals can help to ensure that electrical installations are safe for everyone. Electrical inspectors play a critical role in ensuring compliance with the National Electrical Code. Electrical inspectors review electrical plans, inspect electrical installations, and enforce electrical codes. Electrical inspectors work for local governments, state governments, or private inspection agencies. Electrical inspectors must have a thorough knowledge of the NEC and other applicable electrical codes. Electrical inspectors must be able to identify electrical hazards and code violations. Electrical inspectors must be able to communicate effectively with contractors, homeowners, and other stakeholders. Electrical inspectors must be able to interpret electrical plans and specifications. Electrical inspectors must be able to use electrical testing equipment. Electrical inspectors must be able to write clear and concise inspection reports. Electrical inspectors play a vital role in protecting the public from electrical hazards. By enforcing electrical codes, electrical inspectors help to ensure that electrical installations are safe and compliant. If an inspector finds a code violation, they will issue a notice of violation to the contractor or homeowner responsible for the work. The notice of violation will specify the code violation and the corrective action that must be taken. The inspector will then re-inspect the work to ensure that the code violation has been corrected. If the code violation is not corrected, the inspector may issue a stop work order or take other enforcement action. Electrical inspections are an important part of the electrical safety process. By ensuring that electrical installations comply with the NEC, electrical inspectors help to prevent electrical fires, injuries, and other hazards. When selecting electrical wiring for a project, several factors need consideration to ensure safety and code compliance. Firstly, determine the load requirements by calculating the amperage of the circuit to determine the appropriate wire size. Refer to the NEC tables, specifically Table 310.15, for ampacity ratings based on wire type and temperature rating. Secondly, consider the environmental conditions. Wiring must be suitable for the environment in which it will be installed, such as dry, wet, or corrosive locations. Select wiring with appropriate insulation and protection for the specific environmental conditions. Thirdly, choose the correct wiring type, such as NMB cable, THHN, or other approved wiring methods for the application. Ensure the wiring type is listed and labeled for its intended use. Fourthly, comply with conduit requirements. If wiring will be run in conduit, select the appropriate type and size of conduit, such as EMT, PVC, or RMC, based on the application and code requirements. Fifthly, adhere to grounding requirements. Ensure proper grounding of electrical equipment and wiring to prevent electrical shock hazards. Use the correct size grounding conductors and follow NEC guidelines for grounding electrode systems. Sixthly, inspect for proper labeling. Ensure that all wiring is properly labeled to identify its purpose and voltage. Use wire markers or labels that are durable and easy to read. Seventhly, verify code compliance. Consult the NEC and local electrical codes to ensure that wiring installations comply with all applicable requirements. Obtain necessary permits and inspections to verify code compliance. The NEC provides specific guidelines for the installation of electrical boxes to ensure safety and proper function. Firstly, select the correct box type. Use the appropriate type of electrical box for the wiring method and application, such as metal or non-metallic boxes. Ensure the box is listed and labeled for its intended use. Secondly, determine the box size. Select the correct size of electrical box to accommodate the number of conductors, devices, and wiring connectors. Refer to NEC Table 314.16 for box fill requirements. Thirdly, secure the box properly. Mount electrical boxes securely to a wall, ceiling, or other suitable support structure. Use appropriate fasteners and mounting hardware to ensure the box is firmly attached. Fourthly, maintain proper box fill. Do not exceed the maximum number of conductors, devices, or wiring connectors allowed in the electrical box. Overfilling the box can cause overheating and fire hazards. Fifthly, protect wiring connections. Make all wiring connections within the electrical box using approved wiring connectors, such as wire nuts or terminal blocks. Ensure connections are tight and secure. Sixthly, ground the box properly. Ground metal electrical boxes in accordance with NEC requirements. Use a grounding conductor to connect the metal box to the grounding electrode system. Seventhly, cover open boxes. Cover open electrical boxes with blank covers or faceplates to protect wiring and prevent accidental contact with live electrical parts. Eighthly, ensure accessibility. Install electrical boxes in locations that are easily accessible for maintenance and repairs. Do not install boxes behind walls or ceilings without providing access panels.